Okay, here's going to be a quick summary of lesson 88, which is about conditional probability. A conditional probability is given a condition that is sure to occur. So given is the key word. We talk about givens all the time. A given is something that's guaranteed to have happened. For instance, if I want to flip two coins and I want to know what the probability of them both landing on heads is, right? Go to a blank page. So two coins, and I want them both to be heads. Well, I could build a tree diagram for that. So the first one could be heads or it could be tails. And then I flip the second one, and it could be heads or tails. And it could be heads or tails. So I have how many total possible options? 1, heads, 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 tails, tails, heads, or tails, tails. So out of 4 options, 1 of those is heads, heads. So 1 out of 4 is my answer. That's just a basic probability. Now, if the question said that I was given that the first one was heads, so the probability of heads, heads, given is just a tall vertical line. So given that coin 1 lands on heads. Well, if they've given me that coin 1 lands on heads, right? I have this tree diagram here, heads, heads, tails, and tails, heads, tails. So they gave me that this is the tree we're looking at. So I don't even care about this one anymore because they gave me, right, given the information that the first coin was heads. So this is the only tree I'm interested in. So there are 2 options here. So 1 out of 2 is the probability that I get heads on both then. Because what the given does is it restricts our size of our sample space, right here in blue. Given the conditions restrict our sample space. And I'll give you an example of that. Now, I'll give you 2 examples, in fact, but you also have a nice rule that we can use to find independence. So we're going to focus more on that in the coming days. All right, so let me do one of these first. Question number 6 says, Andrea is a very good student. The probability that she studies and passes her mathematics test is 17 out of 20. If the probability that Andrea studies is 15 out of 16, find the probability that Andrea passes her mathematics test given that she has studied. So here are the key words. She passes given that she's studied. Now we're going to use this rule here. The rule is actually about dependent events. So let me pull that up from here. The rule is about dependent events, and it's essentially a modification of the rule that we already had. Now here's the rule that we had. We had this one already, that the probability of A and B is equal to the probability of A times the probability of B. The and here means multiplication. But what you didn't know is that this is only for independent events. Where's that? So this is only for independent events. If I'm not sure if the events are independent or if I'm sure that they're dependent, I have to just add a little modifier here. Instead of just putting the probability of A times the probability of B, I slap a little given A there on the end. Now this will work for all events. So I'm going to bring this equation over into our template for the previous one, for question number 6. The equation looks like this. The probability of A and B is equal to the probability of A times the probability of B given A. Now look, B given A is right here. Passes, given, studied. So passes must be B, given is that line, and studying is event A. I hope you have the sheet in front of you because I'm going to be going back and forth from this to my loose leaf. So the probability that she studies is 15 out of 16, and the probability that she studies and passes is 17 out of 20. So here's the info that I can glean from this. for number 6. I can glean this. Passing we defined as B, and studying we defined as A, because there was no A given B. It's B given A. And it matched up to the sentence like that. So, if probability of A and B is equal to probability of A times probability of B given A, and we've already defined that passing is B and studying is A, I'm going to turn these into words. So the probability that she, and this order is actually mixed up, the probability that she studies and passes, right? So study and pass is equal to the probability that she studies times the probability that she passes given that she has studied. So which do we know? We know the and probability. We have that. I believe that was 17 out of 20. Yeah. So this right here is going to be 17 out of 20 is equal to the probability that she studies is 15 out of 16. They gave us that. I'll put these in parentheses. And what we're looking for is this. We need to find this. So we don't know that. Probability that she passes given that she studies. So in order to get that by itself, I'm just going to divide both sides by 15 over 16. And I'm allowed to give my answer as a decimal. So I'm going to take this to my calculator. 17 out of 20 divided by 15 over 16. Enter. It gives me 0.91. So 0.91 is equal to that probability that she passes given that she has studied. So if she guarantees, promises that she's going to study, because it's given here, she's going to study, then she has a 91% chance of passing. And that's how you do the questions in that section. Now let's go on to the back. I'm going to write a little bit less. And we'll talk about cards and given conditions. Now, I'll start off with one easy example because it's really quick. The second question on the front, number 9. Because there are accidentally 2 number 9s. A die is tossed. That's 1 dice. It's a cube, right? I want to find the probability that it is less than 5 given that it is even. So if I roll a dice, here are my options. A die. Here are my options. I can get a 1, a 2, a 3, a 4, a 5, or a 6. Now what the given does, is it restricts my my sample space. So if I'm given that it's even, like imagine that I roll the die and I have my eyes closed, and my friend says, hey, it's even. Guess a number. Well, if I'm given that it's even, then I know it's not 1 or 3 or 5. So this is my new sample space. So there's only going to be 3 total on the bottom. Or you can even think of it as whatever the given condition is. The given condition is even. There are 3 evens. Now how many of those are less than 5? 2 is and 4 is. So there are 2 numbers less than 5 out of 3 evens. And 2/3 is going to be the answer. Okay, so 2 out of 3 there. The given condition changes the sample space, the denominator. So let's do 2 examples from the back. The Regents likes to talk about cards from time to time, so I figured I would show you what's in a deck of cards. These suits are called clubs, and these are called spades. Every one of these has 13, so there are 13 clubs, there are 13 spades, there are 13 hearts, and there are 13 diamonds. So if I wanted to answer a real simple question, the probability of getting a heart. There are 13 hearts out of 52 total cards. 13 out of 52 can also be simplified to 1 over 4. Now let's do a given. Probability of a heart given that it is red. So the given condition defines my denominator. So reds should be my denominator. How many reds are there? Well, there's 13 here and 13 here. 13 hearts and 13 diamonds. So there are 26 reds. Now, how many hearts are there in those reds? Well, there are 13 hearts. And this is going to simplify to 1/2. Now let's do a union. Probability of 8 or 10. So this is equal to the probability of 8 plus the probability of 10. Now there are 4 8s over 52 total plus 4 10s over 52 total. So it's 4 and 4 is 8 over 52, which can be simplified, but I'm not switching to my calculator to do that. Let's do one intersection. Probability of a face card and a black card. So I need to get both. So how many cards are both? Let's see. How many of these cards are face cards and black cards? I'm going to switch to a highlighter because that would be more useful right now. Well, this jack is, this queen, this king, this jack, this queen, and this king. These are all black face cards. So there are 6 out of 52. And so 6 out of 52, and you can simplify that with your calculator or divide them both by 2. And that's really all I'm interested in covering. Anything else you can ask me tomorrow in class.